Hi, my name is Violet MacAvoy, and this is my project. When water temperatures rise due to global warming, vital coral reef nurseries expel the symbiotic algae Zooxanthellae that provide them with their main food source. The goal of my experiments was to create a heat-resistant strain of algae using different combinations of the mutagens UVC light and hydrogen peroxide. I first got into corals after a visit to Catalina Island, where I observed healthy corals in the ecosystem. I wanted to keep our corals from going from this to this. So I set up the growing conditions for the algae. I grew the Zooxanthellae for 3 weeks at normal temperature. For 2 weeks, I mutated and grew the algae at a slowly increasing temperature. The flasks being mutated with UV, I exposed the Zooxanthellae to UVC light for 10 minutes at a time and left it in the dark for 12 hours. The flasks being mutated with hydrogen peroxide, I added 0.28 mL of 6% chemical grade hydrogen peroxide to the flasks at a time. I did this near the end of the 2-week period because once the hydrogen peroxide is added, it cannot be taken out. After I created the new strain of algae, I tested it using many different methods. I grew it for 18 days at 33.3 degrees Celsius consistently. I also separately tested the algae on petri dishes, but only obtained qualitative observations. The main testing method, a chlorophyll extraction, was used to assess the chlorophyll content in each flask. The test was assessed 6 times throughout the 18 days. This test was an erythrocyan spectrophotometric dye test to evaluate the health of the algae. Only dead cells absorb erythrocyan. Over the course of the experiment, I used this test 8 times. The test was used to evaluate optical density. I coined this test the spectrophotometric optical density test and used it 8 times over a period of 18 days. I collected 3 samples at 3 different heights in the flask every time I ran this test. With 3 main testing methods, I also ran a Secchi stick test and a petri dish growth period. For this experiment, I collected 608 individual points of data. Chlorophyll concentration was spectrophotometrically determined using the Jeffrey and Humphrey equations for dinoflagellates 1975 and then was averaged. This erythrocyan test is unique because when the data is negative, it means the cells are healthy. The blank from this test was dyed. On the graph, this means the lowest bar on the graph is the healthiest algae. Thus, the results from both flasks were averaged. Spectrophotometric data, all 3 trials were averaged for all days and mutagens. Then the difference between each day and the first day was evaluated. From the cumulative observations I collected, when H2O2 is combined with UVC light as mutagens to create more temperature and penetrable strain of coral Zooxanthellae, it produces the healthiest, densest, fast-growing population of algae at a high unnatural temperature. When H2O2 is used alone as a mutagen, it produces an algae that is able to produce large amounts of chlorophyll at a high temperature. This information can be used to help guide us to a thriving future for coral.